Good morning and welcome. Welcome to the next round of Scriptball. How many of you have been to the Scriptball before? I see some familiar faces. All right. Okay. And how many of you are new? Just want to make sure how many of you are asleep. So that's good. So what we're going to do here is, change it up a little bit. Okay, it's going to be a very fun-oriented session, but a lot of content. We have really the gurus of the respective languages that run really well on the JVM, and they're going to do 2 rounds, and at the end, you, the audience, are going to pick the winner. Okay? Hey, all right. I'm going to do some, I'm going to make some stupid comments, but the speakers themselves, will
also say stupid things.
We will also say stupid things. Okay. And essentially, what they'll do is, we're going to make it like a, election round or something like that. So there'll be a rebuttal round for each of the speakers. Okay. So we have 2 rounds. At the end of the 3rd round, we are going to pick a winner. Okay. Last year, I chickened out and I picked 2. Okay. But this year, we're going to keep clapping until we pick 1 winner, okay? So it's up to you guys. All right?
Groovy wins.
Yeah. All right. So are you guys ready? Yeah. All right, let's go.
Hey, come on.
Rex, I mean, these guys may need to go up because people can't see them sitting down typing.
All right, yeah, they'll get up and do something. All right. All right. Okay.
Because Dick's a good-looking guy, and the people at the back want to see Dick.
Okay. So my name is Raghavan Srinivas. I'm not going to say more. Go by Rags. Yeah, where's my hat? Good question. We'll talk about it later. So I'm not going to introduce myself, but move on to Scala. Representing Scala is Dick Wall.
Thank you. Next request, I'm standing. There we go. My name's Dick Wall. I've been working in Scala for about almost 4 years now. Partner with Bill Venners at Escalate Software, where we do Scala training and consulting. And go Scala. So, is my screen up? Are we doing this now, or are we doing the intros? Intros.
That's sorry. All right. The gentleman to the next, representing JRuby, is Nick Williams, Dr. Nick Williams.
You can clap now. My name's Dr. Nick Williams. I work at Engine Yard. We primarily, we're a hosting company. Well, platform as a service is that fancy new word that you in the Java community haven't needed to know about. For mostly Ruby and PHP, and so one of the things we've been working with is JRuby because it just makes Ruby applications so much more awesome. But first we have to convince you to build Ruby applications. So for the next half hour, that's what we're going to do.
So gentleman to the right is Aaron Bedra, representing Clojure.
Hello, Aaron Bedra. I work for Groupon, where we use all kinds of different Java technologies, Java, Groovy, Clojure, JRuby. I think most of the things here, actually. But, Clojure's my favorite.
All right. And last but not the least, representing Groovy is Guillaume Laforge.
Thank you. So I'm Guillaume, and I've been working on Groovy for the past 8 or 9 years, and I'm working for Spring Source. So don't hesitate to come and say hi on our booth, and I'll be representing Groovy, obviously.
All right. So, gentlemen, you know the rules, right? But just for the benefit of the audience, we have about 4 minutes for each round. Okay, so I'm going to warm them.
Just got less. In a series of emails between this group, that number has changed 7 times.
All right, Nick, you have a problem with me? All right, so it's going to be 4 minutes, stretchable up to 5 minutes. But essentially, I will give them a warning at 3 minutes, and then any of you speakers will have an opportunity to either comment, compliment, or criticize, or do whatever you want, about the other speaker. Just reserve your judgments for the best, because you will be given only 2, okay? Or maybe 3, all right?
By 1 Aaron.
So 4 minutes each round. The first round is the language round. The second round is the community round. So pay attention, and you will pick the winner. Okay. So just as a show of hands, how many of you have already picked a winner? All right, you guys get out. All right, let's get started. You ready?
I am ready.
All right, representing Scala, Dick Wall. All right, let me make sure I get the right one.
Testing. Oh, it works well. Scary. Okay. So every year I represent Scala at the Scripting Bowl. It's always interesting because I don't really consider Scala to be a scripting language as such. It can do it, but it's the only statically typed language that's represented here. So every year I do the same thing, which is to emphasize the scripting-like nature that Scala can have. So this year we're going to look at something that has long been the domain of languages like Ruby and Rails. We're going to set up a website real time. So I'm going to use the play framework for this. I'm going to say play, new. I have nothing, just in this directory, I have no J1PR created. I'm going to say play, new, J1PR. And you're probably wondering what this is. I've just created the application and made it a Scala project. J1PR is short for Java 1 Party Review. I figured that was a good thing to have at Java 1, so that next year everybody can benefit from your wisdom of which were the best parties. So I created that. I'm going to change into the directory, and I just say play, run. And that's going to grind away a little bit. It does take a few seconds to download the internet the first time, but I will show you some of the code while we're waiting. So very simply, it's a model view controller setup. Play, there's a application that sits at the top of everything. That's your main place, main point of entry. Index is just an action in this case, and that's what gets hit when you go to the home page. I've got an HTML page that's also very simple. There's a wrapper around it that does a bit more. So you'll see that in the eye candy that comes up. Configuration file and the routes. And basically that's the application that's been created. So if we have a look at this thing now, it's running on localhost 9000. Hopefully, let's see what it's doing down here. Yep, it's cranking away, and there we go. So your new application is ready. We've already got an application up and running. Very Rails-like, you might say. Now what's really cool about this, though, is, again, remembering that Scala is a statically typed language, it's compiled, is I can come in here, you can see my page, it says your new application is ready. Well, my self-esteem is a little low today. I think it was the party last night. So I'm going to say, you look fabulous today. And just save that, and let's come over here and reload. Wow. How's that for a statically typed language? So what's going on here is that, and while I'm talking, to make the most of the time, I'm going to run my first script. This is the scripting bowl. So in order to save time, I actually created a script called cheat, which will copy a bunch of files over. That is my next version of this application. Don't worry, I'll dig into it. So what's actually going on here is that Play embeds the Scala compiler inside of it. And it uses the fast form of the Scala compiler, which is aggressive at optimizing away what work that it doesn't need to do. So as time goes on, this gets faster and faster, and you get scripting-like turnaround for developing your web application. And
3 minutes.
3 minutes? Okay. Throughout this application, I won't be restarting the web server at any point. This will all be live changes. So, okay, let's see what this has made of my application now. I'll talk about what's going on here, but the first thing is I've now created an object model, and amongst that I've created an evolution SQL script. And when I hit the site, it says, you don't have a database for this. I found one. I found a evolution script. Do you want to run this? So I'm just going to say apply the script. And then I can actually, this is my application running on the same thing, and I can put in the Java posse is the organizer of the party. I'm going to give it a 5 this year because there was no BOF. Try harder next year.
Your fault.
Yeah, it is my fault, actually. So anyway, that's that. The code now, Not a lot of extra code here, and I think it's pretty readable. So we've got a new form, party form, where we've got an organizer, a rating, and a review. We've got an action to actually add the form when the post is submitted. Our index.html now has the form elements put into it, and there's some helpers. It's not pretty, but it's functional. We added just a default database driver, so these 2 lines here are new, just to add the database driver. And then we've added one new route, which is our add party post request. And that's really all the changes that I've got. The other things are the SQL code, which is the thing that runs the schema evolution, and then data accessor. And this is a lot of code. I'm going to come back to this one in the second scripting thingy when I have more time. So that wraps it up for my first part of this. I will hand it on to Nick.
All right. Thank you, Nick. So, gentlemen, any comments, questions, just bowled over? Or?
Wow, speechless. That's what I was going for. I can see you're absolutely awed by the fact that a statically typed language can be that reactive.
It reminds me of other frameworks like Grails.
Oh, I completely agree. I'm showing that we can do it too.
Oh, right.
I was surprised it didn't take all 5 minutes to compile.
Yeah, exactly. And actually, seriously, it does come down to most changes take 2 or 3 seconds to actually show up. It's a fast enough cycle that it's not painful.
For small classes.
Sorry?
For small classes.
So the way the no, but seriously, to answer the question, the way the incremental compiler works, it is very aggressive at not redoing any work. So it will actually avoid even recompiling an entire class if it can get away with just recompiling a single method in there. So it really is working hard at keeping that time down.
So transitive doesn't take additional time then?
Right. Usually.
Usually.
Moving on. Nick, you ready?
I'm ready.
Go.
All right.
Go, Nick.
So the reason you're all here is because you want to see JRuby. And I appreciate that, and it's really nice of you to show up and bless the others with some attendance. And I think that's great. I just want to give a sort of a status, or one of the powerful things about JRuby is that you get access to. Now the others might be able to tell me this is not correct, but I mean one of the things JRuby brings is all of the Ruby universe. So you've got all the wonderful Java stuff that you already know, but then as it sort of says here, 45,000 different projects and gems that people have put up, or versions over time. We're almost cracked 1 billion downloads, so every time someone goes in production, every time someone creates a new app, downloads a new gem, and I don't know if that's good, bad, or indifferent, so I went back to last year where I actually showed a very similar slide, which I would never normally have such preparation, but I feel like I'm actually really prepared this time, and it actually has tripled since then. So in the last year, it's really impressive the amount of new projects that are coming out in that Ruby community. So one of the great things about this coming to JRuby is that you get all these innovative ideas and new spaces that people go into, and combining them with obviously the wonderful integration that the JVM or the Java universe has. Vice versa. If I go to a Ruby conference, I talk about the incredible integration that we get through Java. The tool that we have is for describing absolutely what you want without there being any variation to it. It's called Bundler. And allows you to both say in a sort of a high level, this is the projects I want, but when you freeze this going into production, it actually explicitly describes everything you get. So when you go from development to production, there are no discrepancy whatsoever. Because in the Ruby community, we have a couple of different ways to go into production. One is, which is what I'm going to show you, how to create a WAR file. The other is where we just ship the entire source code, and then in production it gets compiled.
3 minutes.
Really simple way of turning it into a normal Ruby app into a JRuby app. There's a couple of small differences. So if you've ever heard of Rails, and everyone is going to do a demonstration of how wonderful their thing is compared to Rails, so I don't need to do that. I'm going to show you a micro framework, which is really quite popular, which has been copied into other frameworks, called Sinatra. It also shows really nice syntax that you get. And obviously, the reason you're here is because all these scripting languages have nice syntax, and syntax is what makes us as developers feel good about what we're doing and comprehend it. Really simple way of as you already know, packaging in parallel, running each in parallel, each different app. So I just want to show, and I'm not going to pretend to type. Look, my hands are in the air. This is the magic that JRuby has. It's called scripting. So what we're doing here is just quickly pulling together a really small micro app. And so this bundle gem file of describing what dependencies we want, and then pulling those down a bit like Maven. You can actually bring in Java jars and describe them in this bundle experience. There's a mapping between Ruby and the Maven universe, and you can sort of pretend that a Maven package is a Ruby gem. Now we're just going to build out a real one-page script. I think it's great to demonstrate the Play framework. I think it's a really impressive piece of technology. Sometimes you do just want to create little things, little endpoints, a little script that perhaps you run inside with the rest of your main app, and can talk to it locally but produce a little endpoint. And this, if you could just pretend that this could be talking to your database, this could be talking to the rest of your Java app. And so Sinatra is a really powerful thing to know about. The downside is perhaps you have to agree with me that JRuby is the best. And, but I mean, we could all do that. So at the end, when Rag says, who's the best, you say JRuby, and I will laugh at Groovy, who normally wins.
Yeah, I can see that.
There's
Nick,
hope.
you prepared this time as compared to the last year, right?
I think this is spectacular, isn't it? So a really simple way of getting a WAR file, loading it up. You can run it standalone, and obviously as a WAR file, you can throw it into Tomcat or any of the other ones, JBoss, etc. So, Rags, thank you very much for letting me have a turn, and now I appreciate the opportunity to let the others have their turn.
All right, good job. So, gentlemen, any comments? Yeah, go ahead. Go ahead.
Yeah, I hear you on Sinatra, and I have actually used a very similar framework in Scala called Scalatra, which again does a very similar job of kind of lightweight, just put something out on the web. So I actually think, in all seriousness, those libraries are fantastic.
Yeah.
I've used them for all sorts of stuff.
Yeah, I think that idea of a little micro thing,
Yeah.
just to express things, is great for just, I think most languages, most runtimes have a flavor or something like that, and they're really, really
We've all got
powerful.
them.
We've all got them.
I can't believe you guys are being nice to each other.
Hey, we love each other, man.
Okay. All right, Aaron or Guillaume, any questions, follow-up,
No,
criticism?
Nothing particular.
All right, yeah, let's move on. Moving on to the next one, which is Clojure and Aaron. Let me make sure I get the right one up there.
Does that sound work?
Let's crank it up.
Does it work? Did you hear me?
Yes.
All right.
I said, hello, Java 1.
Clojure's got attitude.
Hello, Java 1.
We can do this all day. All right. So what I want to talk to you about today, because we all have web frameworks, and they're all really cool, is something completely different. I want to talk to you about music as data and visualization as data, basically art as data and code. Clojure has a couple of libraries called Overtone and Quill. Overtone is a wrapper around a library called Super Collider, which is an audio synthesis library. And much in the vein of the processing library, there's Quill, which does video and graphics, OpenGL rendering, things like that. And so I want to show you how to create kind of live art with Clojure. So I'll do another test here. Make sure everything's working here. We'll come and come and come, hopefully get louder.
It sounds like the light bikes on Tron.
It is, but it's really the THX sound.
Ah, okay.
But unfortunately, the mic's a little quiet. So actually, this bunch of gobbledygook you see before you is actually the makings of what you hear is the THX noise when you boot that up and you hear it play. So this is the overtone representation, which is just basically the Super Collider representation ported to overtone that actually makes the THX noise. So you see, actually, you just go down straight to the saw waves and all the other elements of making audio, and you produce it that way. And so that's all good and well. But you can also take other things and sample them. So you can take audio files, waves, whatever you want, to play them back, create more interesting noises. Maybe I'll bump my volume up a little bit just so we can... there we go.
Yeah.
Look at that. So we can make these really weird, funky noises.
This is like all of the soundtrack of Tron.
Yeah, we can get this really cool stuff going. So
This isn't very enterprising.
No electronic music demo would be good without some dubstep. So what I've got here is actually basically a bunch of different frequencies, sounds, noises that all play together to make myself some dubstep. And I've got a nice low beats per minute thing, but I think that I might want to speed it up just a little bit and get closer to Dance Party. And maybe add some Skrillex into it.
Yes! Oh my God!
We can get like a dance party going and actually start making some live music. So that's cool, but visualization is also really important.
3 minutes.
So what I'm going to do is bring in Quill. And so behind my screen, it's a transparent window. I have this Quill session started already. So I'm going to show you my sphere. My sphere is cool, and it's an OpenGL. And all I really have for my sphere is just a few different things. I've basically the math to make a sphere is all it really is. But you see this really cool thing called vol tap. I'm actually tapping the volume from overtone. So I'm going to make my sphere dance. So if we come back here, and maybe we'll try, let's see, come back here and try our noises again. Let's get some coins. My sphere's dancing. So we really want to make this work. We can actually make a little Java 1 dance party. Let's make our beats per minute even higher now. And now we have audio and we have visual, and we can have Java 1 dance party. So now I can take this and just start evolving it. And really what is done here is you start with a blank screen and start with nothing at all and code this all live, right? You start with small noises, you evolve the noises, you evolve the pictures, and you end up making just live art, right? This is a really cool thing. There's actually quite a few people doing this. You might see slides all over the internet of people doing these live performances and making this art. But if you don't want the other stuff, you can actually make kind of a static background. So let me hide my sphere and do this, right? So I can have a static background. This won't respond to the beat, but we could actually change the frame rate on this. So we might want to say,
You're out of time.
In the crowd, thank you.
I'm sorry?
Epileptic people in the crowd.
They thank me. I'm sorry. But you can respond. You can change the frame rates around. You might make your frame rates a function of your beats per minute, and make sure that kind of your visuals line up with your audio. But we have this nice kind of framework to do this stuff. So go out and make really cool art with Clojure. There's all kinds of great things you can do with Clojure, but sometimes it's fun to kind of detour off from the generic enterprise web framework stuff and do something kind of out there.
Cool. I just heard that Pearl Jam is not going to show up tonight because they just can't compete with Aaron.
What can I say?
All right, moving on. Any questions? Gentlemen.
I have one comment, which is that I think Aaron has created this new art form. It's going to be like Deadmau5 on stage for people, as long as they don't mind lots and lots of parens. That's the thing.
They're code hugs. They're just hugs for your code. That's all they are.
Okay.
Yeah. How many patterns really on the code?
Actually, if you look at some of the other code, you might find less parens. They're just in a different place. They're rearranged. I just put them in a different spot. That's all.
Different way. Okay.
Yeah, that's all.
Guillaume, any comments?
Okay, if I could. So last year, for the people that were here, I did a demo. The second talk I gave was given that two of Ruby's biggest successes were Groupon and Living Social. I showed how you too could go home and build like a group coupon site and get rich. Since one of my learned panelists chose to work for Groupon, I do find it bemusing that he would then go and talk about something novelty like not selling coupons, which is obviously a core business. There is no question for the panelist.
He's interested in winning the script ball. Anyway. Yeah, moving on. Guillaume and Groovy.
Yep.
You got 4 minutes.
Thank you.
All right.
If you... Okay, that's me. You hear me well? Okay, cool. So, I'm going to speak about Groovy 2 in some more detail this afternoon, so join me for that session afterwards. So just wanted to make a little ad for my other session. So for this first round, I'm going to show you several aspects of the language. For domain-specific languages, the new features regarding static type checking and static compilation in Groovy. Despite being a dynamic language, you can statically compile stuff as well. And still, also, its dynamic nature with the Groovy builders. So, who's playing chess here? Okay, a few. So you probably know that notation already for expressing the moves on the chessboard. So in this example, I'm going to try to create a DSL a bit more verbose. So this those moves there generate that kind of chessboard state. And I'm going to show you how you can create plain English sentences using the dynamic, the domain-specific language capabilities of Groovy. So it's a way more verbose version, but you can imagine that applied to your business domain. And so this kind of method calls can be made by using what we call command chains. So it's a way of dropping dots and parents. So some languages like parentheses, but some others like to drop them. And it's a way of... Oops. Cheap shot.
Yeah, I never thought Guillaume was
one. And so when you see something like that, pull request on GitHub, it's actually equivalent to mixing method names and parameters. So you have an alternation of method names and of parameters. You can also use Groovy's named parameters, which is in the end equivalent to that kind of call. So it's really chained method calls, but where you can remove dots and parents. And you can also use named parameters. Check that margarita tastes good. That reads pretty well. And this is a named parameter. Okay? And on top of that, so when you create a DSL, you may wish that your users are warned when they make some mistakes, some typos, and things like that. And that's why we added static type checking to Groovy 2.0. So I won't go into details much there. And I'm also mentioning that you can also statically compile your Groovy code to get the same performance as Java bytecode. And yeah, some numbers with static compilation, but I'll go deeper into that in my session this afternoon. So let me show you some code. Okay, so what I want to do is be able to define such sentences there. So I've created several things like some ways of representing the squares of my chessboard, the different piece types, colors of the pieces, etc., and different other classes for the piece, for the different moves, and so on, and also how to define the initial state of the chessboard, and how do I do the actual moves? It's because I have some methods, like white and black are methods, which take piece type as parameters, which return yet another move, on which I can call from, so where is the move class? The from method and to method. And in the end, I'm able to call things like that. White poem, that's a method call, on which returns something, on which I call from E2, which returns something, on which I call to E4. Okay, and then another...
4 minutes.
Okay, thank you. And then another aspect is that I'm going to use at that, in the end, the builder, which is a way of representing hierarchical data structures. So if I run my little script here, up Groovy chess DSL, it's going to generate that. So let me reload. Well, it's the same one, so it's already the same one. So I've got some CSS and so on, and it's generating that kind of chessboard And what I forgot to say is that, as you noticed there, perhaps, there's an annotation here called type checked, which does the type checking. So if I made a mistake there, like E or something, or yeah, whatever, when I try to run that, well, I should compile first, but it's, it should be complaining. Oh yeah, that's not the right place. Well, anyway, I think I'm running out of time, but you'll get compile errors for when you make some mistakes. So I'll have to figure out why it didn't do that. And then you can see, so back to the slides. You can see the hierarchical structure of the HTML thanks to nested method calls taking closures, which in the end generate the same kind of hierarchical structure. And that's it. So you'll notice the Java-friendly syntax, like how I define the enums and so on. That looks like Java. It's very easy to create domain-specific languages with Groovy for your own business domain. And you can even type check your DSLs. And you can also get Java-like performance if you use static compilation as well. And that's it for my part.
Thank you, Guillaume. That kind of reminds me of the first program I wrote in Fortran, when I did the Knights tour. I guess just like fashion, computers also, it comes back around in 20 years or so. Anyway.
Rags, I think it's a bit rough to associate Groovy with Fortran. I think that's rough. It's harsh, and you should ignore what he said and not vote for it anyway.
Okay, I didn't mean that. Any other useful comments?
I just want to ask if writing chess DSLs makes you any more popular in high school than being in the chess club makes you.
That's a good question.
Music does.
Does it get you beaten up at chess club?
All right, you guys ready for the second round? Yeah? Everybody awake still? All right, gentlemen, are you ready?
Yep.
All right, let's bring it to closure here. Oh, I didn't mean that.
That's cool.
Let's go.
I need the screen.
Yeah.
Please, Rex. Okay, so what do you guys think of my application so far?
Hang on, it's not up yet.
Really?
Ask again.
What do you think of my application so far? Personally, I think it sucks ass. I mean, look at that. Would you use a site like that? I liked it better when it was telling me that I looked fabulous today. But anyway, this is the community round. So before I start anything else, I'm going to do something very quickly here, which is to say git push Heroku. I'm doing this because it takes a little while to get going on this. So then I'll keep talking. Okay. So coming back to this, like any good software engineer, in the time in between, I've done a little bit of work because, you don't always wait for the demo to get stuff done. One of the things I did was checked in my code to Git because I didn't want to lose it because, frankly, wouldn't you want to keep a gem like that? And anyway, as I also initialized a Heroku, what do they call that thing? The dyno, a Heroku dyno, which is a little home for it. And at the moment, it's actually pushing my application up to Heroku. So it's going to take a little while. It does take some time for Heroku to do its thing. In the meantime, another thing that our application was pretty naff at was you could put data into it, but you couldn't see that application. Now, being a kind of community guy, I didn't want to just put a list of stuff up on a web page. I wanted a whole JSON back-end server thing that people could hit and find out in their own programs what the best party to go to. So I created this new method called list parties, and it uses a library. And this is one of the great things about Scala that you really do come to appreciate is for a statically typed language, the amount of effort that the libraries go to make you comfortable is pretty staggering. And I'm using this library called Jerkson, which was written by Coda Hale. It's based on the Jackson library. And what I can do now is take a list of parties that I've got. This is from my database handler. I'm taking the list of all parties, sorting it by 10 minus the rating. So I'm getting the ratings in best to worst for the parties. And then I can just say OK, and then generate the JSON of that list of parties as application JSON. This is a good chance to demonstrate something else here, which is that I am not using an IDE for this. I really wanted you guys to have the full
3 minutes.
scripting experience. So no IDEs allowed here. So I'm using a text editor for this. If I deliberately make a mistake in this and go back out to here and reload, it actually gives me a compile error in the web. So I can go straight to that and fix the problem. It says ask is not a member of simple results string. So let's change that back to as and run it again. Okay, so let's see how our it's launching. So we're almost there. So what I've been doing is I've actually put this stuff up onto Heroku while we've been talking. So now we're in the community space. Anyone can use my application. So here's my URL. Let's get it going on Heroku. Oh, I could do that. Oh, yeah. You know, I'm going to do this because I'm not sure which browser it's going to open. And I'm not sure what's in that browser that it's going to open. So I'm going to keep to my script. So there we go. Okay, so here's my wonderful application. I can put some data in it and say scripting bowl. It was a 10 because Scala won this year. That's fantastic. So yeah, that was a 10 out of 10 for me. And there you go. There is no. Oh, there we go. Just took a little second there to compile something behind the scenes. So there's my application. Now, I got to say, I still think that kind of sucks. And in the best
4 minutes.
In the best demo style, here is one I prepared earlier that sucks less. So I got a little bit of help with this one. This is my pimped up version of the party thing. For one thing, I can hit party undoed. I've got some validation in here now, some HTML5 validation. So I have to fill it in, and I can say scripting bowl. The rating is 10, again, because amazingly enough, Scala won yet again. Wins. Yay. And hopefully, there we go. So there is my demo. 0 to deployed Heroku application in Scala without a single web restart in 10 minutes. Actually, 8 minutes, I think.
All right. You know you're losing points if you say 8 minutes, right? You should say 4 minutes.
Well, 4 plus 4, yeah.
All right. Okay. All right. Any comments, gentlemen?
Does they want to comment?
Yeah. Does anybody want to comment? Yeah, we can open it up to, if you can keep it short. No comments?
Wow.
Just checking.
I honestly don't know if that's a good or a bad sign.
Yeah. All right, moving on. Nick, you ready?
Yep.
All right, let's go for it.
I was just checking some of the submissions to your app, and I noticed that that a couple of people are voting for JRuby, which is great.
I bet it's Nick.
No. So I wanted to take an opportunity to teach you something. So we had, actually the music thing was pretty cool for all the smart-ass remarks I made. But if you're running production systems, and more people are in charge of at least the DevOps part of being responsible for your thing running production, it's not just throw it to someone else and say, here's some fun for you. So being aware of what your system's doing so you can code it differently is really important. So logging is a certain thing. So something that's come out in the last couple of years and is growing in popularity for people who can't afford to buy Splunk is Logstash. Who can't afford to buy Splunk?
I don't even know what Splunk is.
Who doesn't know what Splunk is? That's because you can't afford it. So it's better that way. You're already happier. And so I wanted to show you a thing called Logstash, which obviously in this context runs on Java and JVM. It's been written in JRuby. Kibana, which is used to be a PHP app, is now a Ruby app running that looks kind of like the Splunk interface for searching your logs. And this is so what this system is for all the machines that you've got, the servers you've got, running a little agent on it to collect logs and events that are happening, to put them through into Elasticsearch, and then allow you to come back later on and look for interesting things that are going on, really get an understanding of how your system's performing, or not, if that's the case. Couple of visualizations. So I said, so Logstash does come with an attempt a user interface. And so Kibana is really quite nice, and Logstash not so much. But the point of Logstash is more about the collection of events and putting them into Elasticsearch. So just so, and again, really I'm doing this mostly to teach you something. So you go away, you've said, yes, JRuby was excellent. I voted for them because the guy was just very funny, although a bit egotistical. And, but nonetheless, Logstash, that looked really interesting. The music thing, not so much. And so events could come from anywhere. Logs, you could have middle sections like Redis and queuing systems. The core genius, I think, is Elasticsearch. I mean, theoretically, it's plug and play. You could put other things in, but Elasticsearch really is a nice piece of equipment for you to have, and different ways for you to view it. So what's interesting is why he chose Ruby now for the two different projects, because, well, for Logstash, it was just the thing he liked writing at the time, so that was kind of his choice. The Kibana one was actually written in PHP, and he ended up rewriting it, in part because part of that be closer to Logstash, so he could get more contributions. Because what you write it in can affect, for all what we talk about, the choice that you choose, how you choose to write your app is going to affect who's going to come along and work on it, either for employees or if it's open source where you're going to get contributions. So that language choice is important. So he chose to rewrite in Ruby so he could get more contributions.
3.5 minutes. Do we have a demo coming up?
It scares the crap out of me every time you do that. So loud. Just run naked or something, and I'll get the gist. Naked rags, 3 minutes. All right. But why he chose JRuby, which is perhaps an interesting question, is because of all the things we know. In Ruby, you don't get real threads. You get these sort of funny threads. Well, what you get real threads, except you can't run Ruby at the same time. So whatever that's useful for. So JRuby is really great for that. But the debugging tools are just brilliant that you've got. And one of the things he was able to do when he put it in JRuby was also build a monolithic jar file, which included everything for a demo, essentially, which included Elasticsearch. So you can put this, run it, and get the gist of what's going on, and sort of then buy into the whole system and then start wasting time trying to set it up. The Java universe, again, you get this hybrid of libraries, and some of the libraries were better. Again, so I'm trying to sell you on Logstash. Don't be under any confusion what I'm trying to do. I think Logstash is fantastic, and save a ton of cash and get a lot of appreciation of what your system's doing. 20,000 events a second on a single Amazon one extra large. That equates perhaps to $2,000 to $4,000 a year of Splunk, fees plus equipment. So really is a great piece of software and a great thing that someone's built. And being open source, obviously you can contribute to it. Though you will need to first vote for JRuby and then write Ruby. But you'll be happy about it, and I really think your life will be better for it. So quick, real simple, go there and always keep on the lookout for new and interesting tools that make you better, because that's the profession we're in, partly about language choice, but it's also the things we run around our production systems. And so I think this is a great one, and hopefully you have a play with it.
All right. Any comments on the demo?
More clapping. Hang on, stop. All right, I apologize. That wasn't definitive enough. You weren't sure. It was time for clapping. I'm going to do it again. I'm going to be more definitive, and we'll go, oh, that was, all right, we're good for that. We can do this again. We're professional attendance people. Well, I mean, you paid to come, so that you're professional.
All right, any comments from the gentleman?
My music has logs. Can you log those, Nick?
Yes, you could. I don't know if you could play back the noise. Oh, look at that.
Probably could.
You could, that'd be fun.
All right, anything else? All right, let's move on to the next, which is Aaron and Clojure. Any more music coming up?
No more music. So the things I skipped over because I wanted to get through the demo part was to actually explain what Clojure was for those of you who may not have ever seen it before. Clojure actually is a dialect of Lisp that runs on the JVM. So it actually takes its roots from Common Lisp. Most of the influence in the style of Lisp comes from Common Lisp. It includes the Common Lisp macro system or something similar, and a lot of the choices that were made inside of Common Lisp versus Scheme. But since that doesn't all matter all that much, the real interesting parts of Clojure are actually the data structures. Clojure chooses immutability by default and has persistent data structures. So this is actually the foundation for a lot of really awesome work, especially when you're working in concurrent environments. There's a lot of things you don't have to think about anymore. Clojure also includes software transactional memory, so just that next step of being able to deal with mutable data when you have to and make the right choices. But what really packages it all together is actually harnessing the power of Lisp, right? I don't know if you've ever heard, if you've ever worked in Lisp before or worked with somebody who worked in Lisp in the past, they're always going on and on about the expressiveness and the syntax of Lisp or the lack of syntax in Lisp. There's some really amazing things you can do there. And when you couple that with the JVM interop or the Java interop, you can use libraries from any of these languages as they can consume stuff from Clojure. You really get this really nice power of abstraction over top of anything you're doing. You end up being able to create these wonderful domain-specific languages, or actually even new languages. Lisp gives you the power of the compiler kind of at your fingertips. You can actually kind of, with the macro system and everything else, write your own mini languages inside of your programs. And quite often you do, to kind of get the highest level of expression you can out of it. And that idea of abstraction kind of follows all the way through the libraries in Clojure. It's kind of the idea of composable abstractions. And really what this is, what I showed you today, was just a set of composable abstractions. These are all built on Clojure's core primitives. But what you don't see under the hood is all the stuff that's happening with that music is highly concurrent. There's all kinds of things happening behind the scenes. And the author of Overtone actually just took advantage of what Clojure had to do all this work. He had to think almost not at all, really, to make this work. It was just a very small amount of effort to coordinate, because Clojure did the work for him. So there's some really, really powerful things that you can get from kind of diving into Clojure and reaching in and kind of exploring what it has to offer. These libraries expand out everywhere, right? The practical libraries follow too. We saw Sinatra. There's the same copies there in Clojure. You have Ring at your core. You have Composure, the same thing as kind of Sinatra. There aren't any Rails clones, but
3 minutes.
There's that part of the web layer is different because we have ClojureScript, right? We have the front end. When now Clojure compiles to JavaScript, there are other backends now that people have added. Clojure will compile to Lua, compiles to Objective-C, to Gambit Scheme, which compiles to C, to Python, all these new backends. You can actually write Clojure code and have it spit out a whole bunch of other languages. So the ClojureScript project kind of moved it forward, and that was something that was really interesting. I think I demoed it last year. If you were here for last year's Script Bowl, demoed ClojureScript, and now there's been a lot of advancement. So that combination of being able to write Clojure and actually all of your layers is really compelling, and being able to share that data across the wire, because Clojure data structures can actually travel as a wire protocol. So you get some really powerful abstractions when you have the Clojure data structures travel straight over the wire, because there's a reader built in. So the community in Clojure it's young, right? It's only a few years old. There's been a stack of books, lots of great learning material, and just some really amazing people that have shown up. We have embedded Prolog in Clojure, just all kinds of really great stuff that's come along to kind of change the way you're programming. Not just make it a little bit better, but really change everything and get a lot more power.
All right. So any comments on the demo?
No demo. The demo happened already.
Did you notice the subliminal messages while the sphere was moving? Or?
That's right.
Any
the parentheses have you.
How hard is it to, if you're not used to functional programming, how long does it take before you become a functional programmer and you can think and solve?
That's a great question. So I think functional programming is just, there is definitely some different stuff there. I think Dick will also agree. Scala has a lot of functional concepts too. It's a change in pace. You can learn Clojure and not learn all of functional programming and still be effective in Clojure. But to be maximally effective in Clojure, adding that functional style, that functional thinking, helps improve your programs an awful lot and helps your abstractions an awful lot too.
If you're learning Clojure, should you be let anywhere near a production code base, or is only bad things going to happen?
No, I actually think it's okay. Especially if you're working in smaller teams, it's all right. I think the abstractions give you a lot of leeway. You can definitely shoot yourself in the foot, as you can with any of the languages. But yeah, you can get into a production system on day one and actually be effective, even if you're learning.
All right, moving on. You guys ready to vote after the last demo here? Right? Please don't leave the room until we crown a winner. All right? I'm keeping track, and I've asked the monitors to seal the door. Okay?
The auto guns outside the door are active now. Do not leave.
So I'll continue with my example from the first round, but this time telling you about well, the community aspect of Groovy, which is essentially its ecosystem. There's a very rich and mature ecosystem of projects, and two pretty prominent and successful projects in that ecosystem are Gradle, build solution, and Spock for your testing needs. So the Groovy ecosystem, some of the most well-known projects like Grails, Griffon, etc. And we'll just focus on Gradle and Spock for now. So first, Gradle. So it's a build automation solution using Groovy. So you write your build definition using Groovy. It's got the flexibility of AND, so you can script, if you will, anything. And it's got all the dependency management, oh, there are some typos, and convention approach of Maven. So it's the best of both worlds without the worst of those two worlds, anyway. And it's also a very extensible platform because there are plugins for different things. You can use Gradle, although it's a Groovy DSL for your build. You can use Gradle for building your Scala or C++ projects. There are some very handy tools like the wrapper. You can create a wrapper around the build solution so that people who haven't installed Gradle on their machines can actually launch some batch script to launch the build, etc., etc. And because of its flexibility, Gradle's been adopted by key. Well, there are also lots of companies using it, but I'm just mentioning the open source projects. For example, the Android project is adopting Gradle so that you can build the different flavors and different kind of deliverables of your Android projects. Other projects like Hibernate, the Spring Framework, and obviously Groovy and Grails have moved to Gradle thanks to, for its flexibility. If you want to get started with Gradle, you just need a small Groovy script. So I'm going to use the Groovy plugin for compiling Groovy code. I'm defining the dependency lookup mechanism. I'm going to fetch the dependency from Maven Central.
3 minutes.
And I define the dependencies. And where is it? It's here. So there are many tasks that I can launch. And for example, just to show you, so earlier so these are all the things you can run. And earlier, my mistake was that I had forgotten to save the changes I had made. That's why you didn't get a compilation error. But for example, I'm going to launch Gradle build to build this project. And here I made a typo because I removed the number of the square. And it's going to tell me, because it's statically typed, that, okay, there are some errors. This variable is undeclared. So it's a compile time error and not a runtime error. And well, okay, that's pretty much it. I need to fix the error before moving on up to E4. And then the other thing I wanted to speak about, so no XML, etc. And the other interesting project I wanted to mention was Spock for your testing and specification needs for Groovy, for Java projects, etc. You can write your specifications in Groovy, and it also adopts the principles of the behavior-driven development, well, the BDD approach. It's fully compatible with JUnit, so you can run that in your IDs, in your build tools, etc. And what's nice is it's very expressive. For example, in Groovy, we adopted a feature which was from Spock, which is what we call power assertions or power assert. When you have some asserts, you have a very nice tree view of the things which are going wrong, and you see the values of each sub-expressions.
Time up.
And the last thing, and I'm going to show you this example for real, that's what we call data tables. So where's my test? It's here. So here, I define, so when we do something, okay, I'm going to do the various moves on the chessboard, then I want to check those expectations, and you can also define the values of the different variables which appear there. So square is here, and piece is there, etc. And when you run that, Gradle test, I'm almost done. So I think I made one, or did I fix the test or not? Let me see. Okay, compiling and testing. I think yeah. So you see there's a failure. When I go to the nice HTML report here, it's going to show the nice power assert. And well, you see that instead of I had a bishop, but it was a pawn that I had moved, so I have this this kind of output. And that's it, I think. So for a nice readable test, and you can use Spock for your Java projects. You don't need to have Groovy in your production system, but you can use Spock and Groovy for your tests, for example.
Thank you.
And that's it. Thank you.
All right, before we crown the winner, I just really want to thank all the gentlemen here. They put in a lot of preparation, so a big round for everybody here. We even managed to do it without any bloodshed this year, so which is good.
Yes.
All right.
We're not over yet.
It's not over yet, that's true.
But there are only 4 of us this year.
All right, so let's... All right, let's start from the left, okay, or from the right for you guys, okay? So, Groovy and Guillaume, how many people thought? Pretty good, pretty good. All right. Aaron and Clojure. Pretty good. All right, let me move on to Dick. Oh, I'm sorry. Nick and JRuby. Yay! Pretty good, but not quite as the other two.
Yeah, JRuby! So I'm coming first of the losers at the moment.
All right, Dick and Scala. It seems like I have a problem. This time it may be a 3-way tie. All right, let's.
That does not surprise me at all that you would say that.
All right, let's go back again from the other side. Dick and Scala. Okay, Aaron and Clojure. I'm sorry, Aaron, you tried. Okay?
I did.
All right, Guillaume and Groovy. Okay, with my completely unscientific evaluation, I think it's Dick, Wall, and Scala.
Yay!
Thank you. Thank you all for coming.